Welcome to the AP Calculus BC video for skill number 255. I can evaluate an integral using integration by parts. And with the new unit, the drivetrain unit, what I've got featured here is a bicycle drivetrain. And the trivia question is, this piece of the drivetrain is called what? Or this piece. They have a very similar name. Okay, for this video we're going to use two learning mnemonics to help us memorize these formulas or this approach. The first learning mnemonic is LIPET. LIPET like a pet lion or a lion pet. LIPET stands for an order that you're going to look for things within the problem. So logarithmic, inverse, trig, polynomial, exponential, and trig. I've seen this learning mnemonic used in a couple different ways. Sometimes they'll switch these two because the order is only somewhat important or doesn't always work, but generally this is the best order to go to, and I'll explain when we use this order. The next learning mnemonic you'll hear me make reference to is ultraviolet voodoo. And ultraviolet voodoo helps us remember ultraviolet and then voodoo, because this is the formula that we're going to need to remember for integration by parts. Alright, let's take a look at our first example. Okay, integration by parts is used when you're trying to take an integral and you have two terms that are being multiplied together in some fashion, and you are trying to do this and you're finding that other methods, antiderivatives, maybe u substitution, they are not working. And the formula that we need to commit to memory is the integral of this u dv, this product, is equal to ultraviolet voodoo. So this is our integration by parts tool that we're going to come back to many times. The first example I want to show you is the integral of x squared times ln of x. And I'm going to walk you through this example. If you want to take notes on it, you can. I'm going to go pretty slow, and then I'm going to turn to the worksheet and work us through some of the problems from the worksheet. So, when we're doing integration by parts, usually at this point what we've figured out is that, let's put the dx in there, we figured out that substitution isn't working for us, and so we need to try some other approach. So the first thing we do is we go to our LIPET mnemonic, L-I-P-E-T, and what we want to do is we want to go through this order and see if any of our two pieces fit into this. So our first one is logarithmic, and lo and behold we have a logarithmic. So what we're going to do is we're going to grab the logarithmic first, and we will call that our u. So we're going to call u being ln of x. And then the rest of it we're going to call our dv. So the rest of what we have is x squared dx. And from this, what we want to do is we want to kind of create a table of derivatives and integrals. So if I take my u and I'm going to take the derivative of this, I will get a derivative of du equals 1 over x dx. And then since I'm starting with the derivative on this blue side, I need to create the antiderivative of that. So the antiderivative of x squared dx is x to the third over 3. And this is where we do the ultraviolet voodoo trick. The integral of u dv, so the integral of u dv, is equal to ultraviolet minus integral voodoo. So what is our u term? That is ln of x. Our v term is x to the third over 3. And then from that we're going to subtract the integral of x to the third over 3 times du, which is 1 over x dx. And now we still have an integral here, so it would seem as though we haven't made much progress, but let's kind of simplify this down and see if we can take progress from there. So the stuff outside the radical becomes x to the third ln of x over 3, and then we can take the integrand, we'll pull out a 1/3, and we have the integrand x to the third over x simplifies to x squared dx. And this is an integrand that we do know, something that we can do with simple antidifferentiation that we have memorized. So this whole thing, including the first term, will simplify to x to the third ln of x over 3 minus x to the third over 9. And remember, the 9 comes from, we have the x to the third over 3, when we integrate that, times 1/3. So there's our 1/9. And of course, because it's a indefinite integral, we don't want to forget the plus c at the end. So this is our final answer. And of course, every good mathematician would want to check their work if they were given the time. So the way we could check this is we could take the derivative of this answer and see if it equals our original equation. So if you want to pause the video, I'm going to pause it and write out the derivative. Alright, so I did the derivative. I took the product rule of these two pieces, got that. This was a pretty straightforward derivative. If you go through and start canceling, the 3's cancel, x cancels, this and that cancel, and we wind up with x squared ln of x. So it all works out. Now, what does this look like on the skill test for me? Because this is a pretty convoluted skill. What we want to do, let me do this on the next page. Alright, you'll start with your integral, and I'm going to have you create this table where you identify what your u is and what your dv is. So remember, one of these is going to be your u. Last time it was the ln of x, and the other one is going to be our dv, basically everything that's left over. So that's the first thing that you'll need to do. The next thing that you'll need to do is you'll need to fill in your table. So you're going to need to generate those values by taking the derivative of u. So you'll have, maybe I shouldn't have scribbled there. So then you'll have your du equals something, and don't forget you'll probably need the dx there. And then your dv you'll need to integrate, and when you integrate it you'll come out with some sort of v. So now we have our table filled out. So we've got something like 1 point for selecting the right thing, 1 point for filling out the table correctly, and then 1 point for writing the ultraviolet voodoo equation correctly, and then finally arriving at your answer. So if you went through this process and failed in this process, you would still get a passing score because you did the majority of the work. Let's take a look at some of the problems on the worksheet, and I'm going to work through them largely not talking. I'll kind of play a little piece here and there and then write in, but I want you to follow along on your worksheet. Alright, the worksheet at the very top, the first question is just to write the general equation, which is the integral of the product of u times dv is equal to ultraviolet minus voodoo. And next up we have the little note about lipet. When selecting your u, you should go down the list and look for the following pieces in the order of logarithmic, inverse trig, polynomial, exponential, and trigonometric. Often, but not always, this is the best way to decide between the u and dv. So you'll use lipet to find your u, and then dv will be everything else. So for this worksheet, I'm going to walk you through the even numbers, and you can do the odd numbers. So I'm going to zoom in. Let's fix this. Number 4. They start out by giving us our u and our dv, which is kind of nice. You won't get that from me on the skill test. But if we used our lipet, we would have found logarithmic was our first piece. So if u is ln of x, then our du is going to be 1 over x dx. And if our dv is, I'm going to write this x to the 1/2 dx, then our v is going to be the antiderivative of that, which is 2/3 x to the 3/2. So this would be the table you would want to fill out, and then you want to write the general form of the equation, uv minus the integral of v du, ultraviolet voodoo. So ln of x times 2/3 x to the 3/2 minus the integral of 2/3 x to the 3/2 times 1 over x dx. So that would be the next part in the process that you would have to fill out correctly. And then from there you want to simplify and solve. Go ahead and pause it. I'm going to simplify it and solve it off camera. Alright, so in the first step I simplified my pieces, factored out the 2/3, and then in my second step I evaluated the integral, so found the antiderivative of that. This is my final answer, and because it's an indefinite integral I included the plus c at the end. Okay. Example 6 I'm going to do off camera, and so I would encourage you to pause it and take a shot at it, and then I'll show you my work. So go ahead and pause now. Okay, so I set up my chart, and then I substituted the values into the general equation, ultraviolet voodoo, and then I evaluated the integral and arrived at my final answer. Alright, let's move along to problem number 8. Alright, with problem number 8 they give us the u dv again, which is very nice of them, but if we wanted to we could revert back to using the old lion pet, and we would find there are no logarithmic functions, there's no inverse trig functions, but there is a polynomial, and the x is the polynomial, even though it's only one term, but some people use algebraic rather than polynomial. So if we have u is equal to x, I'll do this off camera and then you can check your work. So the first stumbling point you might get at is trying to remember what is the integral or the antiderivative of 2 to the x. And so try to remember the antiderivative of a to the x is a to the x over ln of a. So then we fill out the ultraviolet voodoo form. When that is filled out, we can factor out the denominator because it's just a constant, and then take the antiderivative of 2 to the x. There we go. Factoring out the ln of 2, and then taking the antiderivative of 2 to the x. And then I took all of this and I simplified it down, and since it's a indefinite integral, we got to remember the plus c at the end. Alright, moving on to problem number 10. Oops, let's make sure that we get rid of this lion. Alright, moving on to problem number 10. We can find a u using our lipet, and again our u is the natural log of 3x, which makes our du equal to 1 over 3x times 3, or basically just 1 over x dx. If we let our dv then be 1 over x squared dx, that makes our v negative 1 over x. Alright, I'll pause it and do the work, and you can do the same. Alright, so there we go. I took my u times v and subtracted my v du, simplified this, found the antiderivative. If you wanted to, you can combine, since they're the common denominator, you could combine this into a single fraction. Don't forget your plus c at the end. Alright, I'm going to save number 12 for in-class discussion, and I'm going to move to the next page. Alright, I'm going to work 14 off camera and just let you see my work for it. This one required us to do a little bit of u substitution and going from dv to v, but there's the work for it. And now I'm going to do the same thing for problem number 16, which when we look at it, we see that what we have is cosine of ln of x. So we don't immediately see a product there, we only see one term and then the dx. So with that, let's try going with our lipet. Logarithmic, well, there's no logarithmic term. Inverse trig, there's no inverse trig. Polynomial, I guess our only term that we really have is the cosine term. So we're going to let our u be cosine of ln of x, which means our dv term is just dx. So let's see what carries out from there. We take the derivative using the chain rule, and we take the antiderivative, and there we have our du and v. So now we fill out the integration by parts. And when we start to fill this out, we might see that we're starting to go into what possibly could be circles. But let's try evaluating this integral. Looks like we're going to need to use integration by parts again just for solving this integral. Alright, so off camera I did integration by parts of this piece, and we've got it here in red. And we've arrived at another problem where we've got this integration by parts. And it seems like we could possibly be running in circles, but remember, this whole thing was equal to our starting function, which was cosine ln of x dx. And I'm off screen, but you might notice that this last integral is the same as this integral. So we could actually combine those as like terms. And so we have x cosine ln of x plus x sine of ln of x is equal to 2 of our integrals, cosine ln of x dx. And if we were to divide by 2, the 2's would cancel, and we would have our answer to that integral, provided we remember to include the plus c. Alright, so to recap, we wound up going in circles until we wound up having the same integral as our initial question. We added this to the right hand side because they're like terms, and we are able to do that. And then we divided by 2, leaving us with our original question on the right side. A very tricky one indeed. They can get trickier, but not for me. From me, I probably wouldn't give you anything much trickier than this, but there are some that will run you in a chain of like 4 or 5 steps of integration by parts. Kind of a nightmare. Alright, finally off camera, I'll do problem number 18, and that should close out the worksheet, at least the portion that I'm doing for you. Okay, here we go. Alright, so I had to do integration within integration by parts, and it looks like I've arrived at a point where I'm going to be running in a circle again. So this is a case where we're going to need to add it to the other side. So let's kind of pull this 4 out and distribute it through before we do that. Since I don't like dealing with fractions, I'm going to multiply everything by 16. Okay, everything multiplied by 16. I will add this to the right side, which would wind up giving me 17 integrals. And then I'm going to divide both sides by 17 to arrive at my final answer, if I remember to plus c at the end of it. And that was a thick problem. Alright, thanks for watching the video. Hope it wasn't too long on you. The trivia question for the video was, what are these 2 parts called? And they are called the front derailleur and, of course, the rear derailleur. Thanks for watching.